हेलो डियर स्टूडेंट्स। जो आज का हमारा टॉपिक है, तो आपने देखा होगा जो हमारा प्रीवियस लेक्चर था। सो वी हैव डिस्कस्ड अबाउट दैट लॉरेंट्ज़ एंड कॉलम गेज, एंड टुडे वी आर गोइंग टू सॉल्व वन प्रॉब्लम ऑन कॉलम गेज, राइट। तो आपको सपोज वी हैव अ प्रॉब्लम दैट वी हैव दिस constant and uniform magnetic field, that is B equal to B naught K cap, right? So it prevails all the space. So that means our magnetic field is along that K cap, right? And what we have to calculate what will be the choice of vector potential. तो हमें क्या वेक्टर पोटेंशियल लेना है ताकि हमारा जो मैग्नेटिक फील्ड है तो दैट शुड बी इक्वल टू बी नॉट के कैप, राइट। So that means we need to choose the potential but in column gauge. So that means हमें देखना है कि column gauge के लिए condition में है that nabla dot A is equal to 0, right? तो उसके लिए हम क्या करेंगे? So and these are some choices. तो हमारे पास we have these kinds of potentials हमारे पास है. Suppose if we take that A will be this one or this or this or this, right? तो हम इसको कैसे solve करेंगे? So first of all, you know that if we write that what is the condition for the column gauge, that nabla dot A vector that should be equal to 0, right? So this is the column gauge condition. Okay. Now if you write now, because we choose now the magnetic field is given to us. So B is our, so that B is equal to, okay. Now if I choose that, our vector potential will be this one, right? So that means if I choose here, if our A equal to, okay. So let's calculate, because our B equal to, we have that magnetic field can be written as a curl of that vector potential. So that means I can write now what's our nebula cross A then. And our vector potential is, it has only one component. इसका एक ही component है, that is first ith component. Okay. So that means this will be equal to, okay. So that means this will be minus b naught x plus y, 0 and 0. So let us solve this determinant. So when you write the first component, that's I cap, so that will be equal to, so that will be 0 here because you take this row and column, so this will be 0, right? Because our j and k components are 0, so ये हमें 0 बन जाएगा. Similarly, when you take the second component, that is j cap, so that will be equal to, so because when you take the j component, so this is this with this, that's partial by partial x, so on this 0, so that will be 0, and similarly this one, partial by partial z on this, because this is partial differential, you have to differentiate it partially. So यहाँ पे आपको लेना है partial by partial z with this one, that's minus b naught x plus y, so that means that's also equal to 0. So you will get 0 here also. Now the third term will be plus k cap. Now k cap, so that is this term. So you can write that. So that will be equal to, so this will be 0. You can write that 0 minus, or let me write it here. Plus k cap. That's partial by partial y. That will be plus partial by partial y into b naught of x plus y. Okay. So it's clear because when you take the k component, so this will be 0 and this will be plus. So we get here. So this is minus here. This should be minus here. Huh? So that means you will get here. You will get here. It will be plus now. It will be b naught. right? Because when you differentiate this, so this minus minus will be plus, so this will be b naught because you will differentiate the second term, so this will be b naught into y because यहाँ से minus आ जाएगा, minus into minus will be plus, so it will be b naught x plus y, and you differentiate it with respect to y, so this term will be b naught k cap. So that means जो हमारा magnetic field है, okay, that it is clear because our uniform magnetic field is b equal to b naught k cap. So that is what we get here. Now let us check the Coulomb condition, Coulomb gauge condition. So that means we can calculate now. Okay, so you write now, well, what will be our that W dot A? So you can write now, you expand this partial, this W as, so what's our vector potential? So vector potential हमने क्या लिया? That's minus b naught x plus y I cap. So that will be equal to, so when you, because this is that you take, there is only the ith component present, so you will get that, so this will be equal to, so this will be equal to that minus b naught I cap. So sorry, this is b naught I. Okay, so that means here our nabla dot A is not equal to 0, as that minus, तो ये किसके बराबर है? That's minus b naught. So that means our that Coulomb gauge condition is not satisfied. So that means we cannot choose this kind of vector potential, so that our magnetic field will be that b equal to that b naught k cap, right? So this is first part. So that means when we choose that, जब हमारा vector potential क्या बना था? Minus b naught x plus y I cap. तो अगर हम अब second choice देखेंगे, if we choose that, if our vector potential will be this one, so let us try both the case. So let's calculate for this. Okay. So second choice is that if we choose that, if our vector potential is, that is V naught, right? So first we need to check that, or that B should be equal to, that should be equal to lambda cross A. That means जो हमारा magnetic field क्या आना चाहिए, क्योंकि हमने already assume किया कि जो हमारा magnetic field है, that should be that V naught, ठीक है. So first this condition should satisfy, and then second that lambda dot A should be equal to, तो ये दोनों कंडीशन satisfy होनी चाहिए. Then we can say that we can choose this kind of vector potential so that our magnetic field will be that V naught k cap, right? So let us calculate first if we take the curl of that vector potential. So that means you need to calculate that. If we calculate, right? And now the vector potential, it has only the gf component, so this will be 0. This is that V naught into x plus y and 0, right? So let's also evaluate this term. So first term will be, so when you take this component, so this will be 0 because when you take the ith component, this partial by partial y is 0, that will be 0. Because now second, this minus partial by partial of this, because it is partially differentiation with respect to z, but there is no z component, so that means ये term b0 बन जाएगा. And similarly, if you take the j component will be, So jth component skip all this row and column, right? So that means this will again be 0. And now what will be our kth component? So if you calculate kth component will be, so that means differentiation of this with this, right? So that means you have this partial by partial x into, okay? So that's equal to, okay? So that means we can, so first condition is satisfied. That means this is the magnetic field that we get here, that's B equal to B naught, B equal to B naught K cap, right? Now let us check the whether it is, whether we can choose this vector potential or not. तो उसके लिए हमें क्या करना है? We need to check whether that Coulomb gauge condition is satisfied or not, right? So let us check that. Okay. Now let us calculate now what will be our lambda dot. So take dot product because our potential is now, that is, right? So the हमारा potential है, when we choose our next choice is that if our A is x plus B naught x plus y j cap, right? Now let's calculate that because it's very clear. So it's very easy because we have only the jth component present. So that means you need to take differentiation of partial by with this one. So we have here that B naught uh, B naught. That's it. Okay. So that means our that nebula dot A equal to B naught. So that means it doesn't satisfy. तो ये कोलम गेज कंडीशन सेटिस्फाई नहीं करता है, तो उसका मतलब ये है कि हम इसको वेक्टर पोटेंशियल, वी कैन नॉट चूज दिस एज अ वेक्टर पोटेंशियल बिकॉज इफ वी चूज दिस वेक्टर पोटेंशियल देन इट शुड बी nebula dot A should be equal to 0, right? Because first the magnetic field is correct, we are getting that magnetic field B equal to B naught K, right? Now our third choice, if we similarly calculate for this one, right? So if I okay, so third choice is that if our A equal to J cap, right? So first, तो पहले हमें क्या देखना है कि that our B should be equal to, and second that nebula dot, right? तो इससे हमें क्या मैग्नेटिक फील्ड आना चाहिए that B naught K cap, और यहाँ से आना चाहिए that nebula dot A should be equal to 0. If these conditions are satisfied, then we can say that this is the correct vector potential that gives us the uniform magnetic field, and that's equal to B naught K cap, right? So you can check तो जो हमारा टॉपिक था, so that magnetic field that was that B naught K cap, which is uniform, right? तो ये हमारा आना चाहिए, right? So let's calculate now. Okay. So let's calculate now what will be the curl of that vector potential. Right? And similarly, so this is our right, because we have only the jth component यहाँ पे present है, so that's why b naught of x and first and the third this I and k components will be 0, right? So it's very clear. Now let's evaluate this term. So let me write it here. Okay. So first component will be that will be I. So when we evaluate first component, so this will be 0 because यहाँ पे हमें ये वाला block करना है, so that means this will be that partial by partial I have 0, so this is 0, and now this partial differentiation of that partial by partial that b0 of x, but this function of x, so this term will also be equal to 0. तो ये term 0 बन जाएगी, and similarly जो second term हमारी है, so when you evaluate the second term that jth component, so this will be again 0 because you block this on vertical and this horizontal. This is partial by partial x with 0, partial by partial with z with 0. So this is again 0. And now let us have a look on the kth component. So kth component will be, so that means you block this one, so you will get here b0 k, right? Because when you block this one, so this one, this and this, so it is that partial by partial x is b0 of x, so this will be b0, and this term will be 0. So that's why I wrote here b0. So that means our magnetic field will be that nebula cross a vector equal to that's b naught. So this is nothing, this was b. So this is correct. तो जो हमारा मैग्नेटिक फील्ड करेक्ट करा है इन जो हमारा थर्ड पार्ट है, थर्ड चॉइस है, तो इसमें हमारा मैग्नेटिक फील्ड ठीक करा है. So let us check the other criteria, that is whether it satisfies that Coulomb gauge condition or not. So let's calculate it. Okay. So what's our lambda naught A now? Now अभी हमारा जो वेक्टर पोटेंशियल है that is b naught x j cap. So you take that. So when because you can check that, तो यहाँ पे हमारा कौन सा कंपोनेंट आएगा, that will be equal to that partial by partial y b naught x. So that will be equal to 0 because you are differentiating it partially, so that means you can, if there will be y component then it will be b naught, but it is b naught x, so this will be 0, right? So that means here that lambda dot a equal to 0. So that means it satisfies Coulomb gauge. So that means this is the correct vector potential that we can choose, so that our magnetic field, that is B equal to that B naught K, it remains uniform, it prevails the all space, right? So this is one of the problem on this Coulomb gauge. Similarly, you can have, instead of that, in previous lecture we discussed about, if we, instead of that, if we want to calculate what will be the choice of that scalar potential, right? So with the help of these two gauges, that Lorentz gauge and Coulomb gauge, so we can calculate. So if the magnetic field will be given, so you can check what will be the choice of the scalar and vector potential, so that our total this magnetic field, or you can talk about electric field also, that means same or that remains invariant if you go from one frame to another frame, right? So this was one problem that I take on column gauge. Similarly, we will, in coming lectures, we will discuss some more problems on these method of images formation or many other problems that will help you in some competitive exams. Thank you.